Hello everyone, this video is about the definition of logarithm. Logarithm is the inverse of exponent. Here we have 2 to the power of 3 equals 8. The inverse of this equation is log 8 base 2 equals 3. So the 2 is the base of the exponent, the 2 here is also the base of the logarithm, and the exponent goes here, so that's the result of the logarithm. Or we can say when we use the log of something, we get the exponent. In Bahasa, we write the base here and we read this as log 8 base 2. Let's try to inverse the equations here. 2 to the power of 3 equals 8. The inverse is log 8 base 2 equals 3. So as you can see, the base, the blue numbers, the base must be the base of the logarithm. So the 3, 4, x, 6 must be also the base of the logarithm, and the exponents in the exponent equation is like the result of the logarithm. So this is the 2 exponent x exponent 2 exponent 2, and the green numbers are the result of the exponential equation, which is called the argument in logarithm. Log 16, log 25, log x. And the opposite process from logarithm to exponents. Again, the base of the logarithm must be also the base of the exponent. So it's got to be 0.5 to the power of something, 1 over 3 to the power of something, 9 to the power of something, 1 over 3 to the power of something, and the exponent in here in the exponential equation is the result of the logarithm. So we put the 2 here because the exponent is 2, 1 over 2, 2. And now the result of the exponent is the argument of the logarithm. So this is 0.25, 1 over 9, 3, 9. You can check using the laws of indices and you'll see that everything makes sense here. The definition of logarithm: if you want to use logarithm, you have to follow the definition that was made by the person inventing logarithm. And this is the rule in using logarithm. The a must be, or the argument must be positive, the base must be positive, and it cannot be 1. So the a and the b must be positive. The a can be 1 but the b cannot be 1. The c can be anything. In your calculator, usually you have this button. This is for log any base. This button, just log, this means the base is 10. And this button ln means the base is e. E is the Euler's number, which is 2.7 something in your calculator. It's an irrational number or transcendental number like pi. Pi is 3.14 and so on. Ln is also called the natural logarithm. So again, ln is log base e. If you use your calculator, log 8 base 2 you get 3. Makes sense because 2 to the power of 3 is 8. Log 1 base 2 equals 0 because 2 to the power of 0 is 1. But if you try log 0 base 2, you'll get an error because based on the definition, this argument cannot be 0. It must be positive. So you'll get an error. And it makes sense because 2 to the power of whatever can never be 0. It's got to be something positive. Now if you try using your calculator, you use 2 to the power of minus 100, the calculator will give you 0. But that is because 2 to the power of minus 1000 is equal to 1 over 2 to the power of 1000, which is 1 over something really big, which means in decimals it's gonna be 0.0000. There are so many zeros, and then you have some numbers, I don't know what, let's say 1 2 3. So because the number is too small, the calculator just round off and you get 0, but actually this is not 0. Actually, log minus 7 base 2, you get an error because this must be positive, and this makes sense because 2 to the power of whatever cannot be minus 7, it's just impossible. And log 3 base 1, also an error because 1 to the power of whatever can never be 3, it's just impossible. 1 to the power of whatever must be just 1. And minus 8, log minus 8 base minus 2, you'll get an error as well because again the definition is this must be positive, this must be positive. Although if you use your calculator, minus 2 to the power of 3 is equal to minus 8. So if you are reinventing logarithm, you can say, well, this makes sense, minus 2 to the power of 3 is minus 8, so this must be 3. But that's not how we use logarithm. It's not in the definition because it'll make the logarithm concept useless. You can watch the derivation video to understand. Without the calculator, find log 49 over root 7 base 7 equals x. So yeah, the first thing we want to do is just say this is x, and then use the inversion. So we invert the equation here. 7 the base to the power of x, the exponent, equals the argument, and 49 is 7 to the power of 2, root 7 is 7 to the power of 1/2. You divide, so you subtract the powers, and therefore the power here x, power here is 3 over 2, same base, the x must be 3 over 2. If you use your calculator, you get 3 over 2. Find the inverse of. So to find the inverse, we use the usual procedure. We call this y, and we swap the x and the y, and we can switch sides because we are solving for y. We want the y to be on the left. Subtract 4 from both sides, divide both sides by 2, and then we use the definition of logarithm. This is the base, so it's now the base of the logarithm. The exponent is like the result of the logarithm, and this is the argument. And we subtract 3 from both sides, so the 3 is now here, minus 3. And we multiply both sides by negative, so minus plus. So in the end, we say the inverse, the f inverse of x equals, yeah, we just change the order, 3 minus, and log base e is the same as ln. If we have this equation, we can solve only by using the definition of logarithm. This is the base, so in the exponent, this is also the base, the result goes here, and this is the argument. And if we solve this quadratic, move everything to the left, factorize, you get x equals minus 3, x equals 2. But the minus 3 must be rejected because we have to check using the original equation. And here, if you plug in minus 3, this base will be minus 3, and it's not in the definition. It is against the definition. Right, that's it. I'll see you guys next time.